jar A. Smells, looks, all it has taste.
Smells like nothing.
Smells like air.
Smells like H2O.
Okay, smells like water.
Smells like body.
No, it smells like air.
What does it look like?
Water.
Can we write this?
No, we're just talking about it. It's clear. Okay, so let's look at B. Okay, give me some ideas about B. Yes. Raise your hand.
It tasted horrible.
Okay.
Not really.
Really?
Yeah.
It buzzes in your mouth.
You're not
Okay,
supposed
hold on to
to.
that. I want to get it from you. Yes.
It smelled like pennies.
Smells like pennies. Okay, smells like pennies. What did you tell me?
Like bubbles up in your mouth.
Bubbles. Okay, bubbles or fizz.
Is it chemical reaction? It burnt your throat.
Burnt.
Well, did you like swallow it?
It has
There's gas.
Yes.
a horrible aftertaste.
Very good. Aftertaste. Good. Aftertaste. Who thinks they know what might have been in B? Yes.
That stuff you use for your, for when you bleed or whatever, like your
Okay,
cuts.
so like an injury or cut.
I don't know what
Okay.
it's called.
Anybody know the name of it? Yes. Peroxide, which is actually hydrogen peroxide. So this was H2O,
Oh, God.
right? So some of y'all that were like freaking out and gagging on the first one, that was just a mental thing probably. Y'all were all set up for bad taste. This is the one that should have tasted kind of weird. And it was H2O2. Isn't that weird? They look the same pretty much except for what?
Taste.
This right here. It has one extra oxygen atom than water does. That's what made the whole difference. Okay? And this is hydrogen peroxide. So just because of one atom can make a huge difference. Now the reason we do this is because we're going to start talking about balancing chemical equations. And a lot of students want to get in the habit of saying, well, if I need an extra oxygen atom, I'll just put a subscript. If you do that, is it still water?
No.
No, it's not. In fact, it's now H2O2, which is bad, right?
Why?
All living things need water to live, but they can't survive on H2O2. Okay, but here's what we can do. We can say, well, what if I want 2 particles of H2O? Is that okay? Does that change it? No, that's like you saying, hey, I want some cereal, but I'm not very hungry, so I'm just going to have like maybe 10 Cheerios, okay? Which won't be very much. But if you want a whole bowl full of cereal, you probably want like 70 or 80 or 100 Cheerios. You haven't changed the Cheerios, you just added more of them. So when I put coefficients in front of things, I'm just getting more and more of those things, okay? Everybody understand that? Okay, that's going to be very important as we go into balancing chemical equations, okay?